let us take two examples. Find the value of the integration over c 3x y square dx plus 2y dy, where c is the boundary of the triangle formed by the lines x is equal to 0, y is equal to x and y is equal to 2. We'll take another example. In the next example, we retain the integrand, but we'll only change the curve c as the boundary of the triangle formed by the lines y is equal to 0, y is equal to x and x is equal to 2. So let us take the second example. Find the value of the integration over c 3x y square dx plus 2y dy, where c is the boundary of the triangle formed by the lines y is equal to 0, y is equal to x and x is equal to 2. So let us try to solve the first example. In the first example, we can see that the entire curve consists of three lines C1, C2, C3, and these three lines are considered in an anti-clockwise direction. That is, we'll first consider y is equal to x and then y is equal to 2 and then y-axis, that is x is equal to 0. In other words, C1 is the curve y is equal to 1 varying from 0, 0 to 2, 2, and C2 is the line varying from 2 to 0, 2, that is y is equal to 2, the line y is equal to 2 varying from the point 2, 2 to 0, 2, and C3 is the line y-axis or x is equal to 0 and varying from the point 0, 2 to 0, 0. So we will be considering these three lines C1, C2, C3. C1 is the line y is equal to x varying from 0, 0 to 2, 2, and C2 is the line y is equal to 2 varying from 0, 2 to the point 2, 2, and C3 is the line y-axis or x is equal to 0 varying from the point 0, 2 to the origin 0, 0. So we'll reduce the integrand in the integral on each line by using these relations. In other words, let us take the first line C1. On the line C1, y is equal to x, and hence in the integrand we use the relation x is equal to y and dx is equal to dy, so that we can reduce the integrand as a function of single variable, namely either a function of y or a function of x. So here we are replacing x by y and dx by dy, and y is varying from 0 to 2. So it becomes integration from 0 to 2. Instead of 3x y square, it becomes 3y cube. The second term 2y is as it is and it becomes 2y dy. And after integration, the first term integration 3y cube will be 3 times y to the power 4 divided by 4, and integration of second one is 2y square divided by 2 or simply y square. And here y ranges from 0 to 2, that is the lower limit is 0 and upper limit is 2. Substituting these values, we get that the integration is 12 plus 4 or 16. So let us call this as equation 1. Now on the line C2, as I told earlier, it is the line y is equal to 2 varying from the point 2, 2 to the point 0, 2. So here x is varying from 2 to 0, but y will remain as constant, that is y is equal to 2. Y value will remain as constant, that is y is equal to 2, and hence its differential coefficient is dy is equal to 0. So in the integrand we will substitute y is equal to 2 and dy is equal to 0 and retain the x terms and the dx coefficients. x terms and dx coefficients. So the integrand becomes integration from 2 to 0 12x dx plus the second term is 0, and after integration we will get 6x square, where x ranging from 2 to 0 and its value will become, for the upper limit x is equal to 0, for the lower limit it is 24, so we will consider it as minus 24. So let us call this as equation 2. But along the line C3, y traverses from 2 to 0 and x has the constant value as 0, that is x is equal to 0, therefore its differential coefficient dx is also 0, but dy is not 0. So in the integrand we will retain y terms and dy terms, but both y is 0 and dx is 0, x is 0. So if we retain, we substitute x is equal to 0, the first term becomes 0, in the second term 2y dy we integrate it from y is equal to 2 to 0. So integration of 2y is y square divided by 2 into 2, so it becomes y square, and y ranging from 2 to 0. So for the upper limit its value is 0, for the lower limit y is equal to 2, its value is minus 4. Now let us call this as equation 3. So when we integrate along the line C1, we have the value as equation 1, and when we integrate on the line C2, we have the value as equation 2, and when we integrate on the line C3, we have the value as equation 3. Hence adding these values from equation 1, 2 and 3, we get the value of given integral along the entire curve C. So I let you to add these values and get the required answer.